let's power through and finish up 4.6. And what we're going to be able to do is utilize the unit circle without the use of a calculator and be able to get the exact values of problems. So what we'll end up doing is like a step-by-step way of solving for theta. I've mentioned it before, these Greek letters are for angles. So anytime we're solving for an angle, well, basically what it boils down to is we want to rewrite it in the sine, cosine, tangent, and be able to figure out what angle would make this a true equation. Pay close attention to this too, and I've said it before, if we start with degrees, we want to end in degrees, and we'll also have 0 to 2 pi radians that we'll have to answer those questions as well. So the first thing is, because we are given secant, it's to your benefit to rewrite this in cosine. Cosine of theta is equal to the reciprocal of that, so it'll be 3 over 2 root 3, and this is why rationalizing is such a big deal. So if you rationalize this, the problem is that some people rewrite this as 3 root 3 over root 3 times root 3 is 3 times 2 is 6, but that's not on the unit circle either, because you can reduce that. 3 divided by 6 reduces to 1/2, so root 3 over 2. So think about it. Where on the unit circle is cosine a positive value? I think that's what this first thing is. And notice that there are 2 possibilities. I expect you to find both. So cosine is positive in the first and fourth quadrant. You may have heard this phrase before, inverse trig. And the reason why we have this phrase is because we know that cosine of theta is equal to root 3 over 2. I left room there for a reason, because to undo cosine is this operation, inverse cosine of that. And what happens is the inverse cosine and cosine cancel, and you're left with just theta. The issue is, if you used a calculator, your calculator can only give you one answer at a time. So what you have to think about, because we're doing this without a calculator for right now, is what is the ordered pair that gives us root 3 over 2 for the x-coordinate? Let me rewrite my circle. What am I talking about? I'm talking about root 3 over 2, comma 1/2, and hopefully you have the unit circle memorized enough to realize that we want the one where the x-coordinate is cosine, and that's at the degree measure, because that's what we care about, of 30 degrees. And let's think about it, is what should be another angle that has the same ordered pair? Well, into the fourth quadrant, we have root 3 over 2 again with a negative 1/2, and that angle would be theta equals 330 degrees. And those are your 2 answers. Now, I do want to point out that if you use the calculator, so let me pull up a calculator real quick. The very first thing that you want to do is make sure you're in the right mode. So click mode, switch over to degree, and then quit out of that. To get inverse, you hit second cosine, and I'm just going to make it a fraction by doing alpha x. Some of you might do a fraction by doing alpha y equals and grabbing that equation. And I lost my cosine already. Root 3 over 2. And as I promised, your calculator will only give you one answer, 30 degrees. So you still, even if you use a calculator, you still have to think a little bit about what other answer would give you a positive x-coordinate that's the same value. And then you get that answer. So same premise, just looking at this one. Think about, so it's already written in the form of sine, so we don't have to worry about that. the third or fourth quadrant, technically you're doing inverse sine of this negative root 3 over 2. So we want the y-coordinate to be negative. And we want to have a positive angle. So that would be the ordered pair negative 1/2, negative root 3 over 2. If it helps, think about where that happens in the first quadrant. Just add 180 to it. If you do it that way, that's 60 degrees. So as you add 180 degrees to 60 degrees, you get an answer for theta to be 240 degrees. But that's not the only time that that happens, because you can think of the fourth quadrant, which would be 360 minus 60, and you get 300 degrees. And I anticipate questions on this, which is totally fine, but I do want to point out, if you use a calculator and you typed in, let me just grab this equation real quick, change that to be a negative, change that to be sine. Notice it gives me a negative answer. Well, that's an issue, because that's not even bigger than 0. Remember, the direction said bigger than 0, smaller than 360. So what you have to think about, let me just change colors, because the calculator gave me this answer going clockwise negative 60 degrees. Well, what would be another coterminal angle to that would be if you add 360 to that. And you get this answer. But even then, that's not all of the answers. You have to think about what else would you have to do to get the other time that sine is negative. Well, it has the same reference angle of 60 degrees, so maybe do 180 plus 60. 180 to go semicircle, and then add the reference angle to it to get up to 240 degrees. Now this next one, you do need a calculator. This is not on the unit circle, so when it's not a unit circle problem, then go to your calculator, exclamation point, and to find theta, as I mentioned, you do inverse sine. And again, pay close attention to the directions, because at any point I can switch from degrees to radians, and you should be good now. So let's talk about it. So get your calculator out. Second sine of point, I already forgot what it was, 735. And we get one answer, 47.307 degrees. I already forgot what it was. 07 degrees. So think about it. Where else is sine positive? Right, so one of our answers was this way. Sine is also positive in the second quadrant, and think about how the reference angle needs to be the same. So what I would do is think about, okay, so this 47 and this 47 must be the same, so I could do 180, which is a semicircle, and then take away that reference angle. So 180 minus 47.307. And if I would use the calculator, I would just type it in this way of 180 minus my answer to get the perfect answer, 132.693. Is your second answer for theta. Same thing happens for this one. So, whoops, theta is equal to inverse cosine of negative 0.482. Just go to your calculator because it's not in the unit circle. Just double checking I typed it correctly. Hit enter, and we get 118.816. That's not your only answer, because you have to also think about another time that cosine is negative. So what we just found was that this angle is a poorly drawn angle. Well, where else is cosine negative? in the third quadrant. And there's several ways you can do it. I'll let you ponder for a second what you could do. Like you could figure out this angle and do 180 minus that, figure out this angle, and then take 180 plus that to get this. But my brain works a little bit differently. I know that these need to match up this way, so I would just go clockwise and do 360 minus that angle. It's just how my brain works. You don't have to do it my way, but my way does work. So I would just go to that 360 minus that answer and get 241.184. Remember 3 decimals. So here's another one. I would rewrite this, because remember cosecant is 1 over sine. So I would just rewrite this as sine as 1 over negative 1.235. And then go to my calculator. Second sine. It doesn't matter where you put the 1 on it. Now, that's wrong, remember? Negative 54. .086. But why is that wrong? Well, back in the directions, we only want answers bigger than 0. Negative numbers are smaller than 0. So what does that negative number even mean? So that means we went clockwise. This is a poorly drawn picture, so how do we get it within? We can add 360 to it. .932. So that's one answer. But even then, that's not your both answers. So remember, this reference angle would be 54.086. So I would think about, okay, well, it has to have the same reference angle over here. So think about doing 180 plus that number. There we go, 234. I could have done that in my head. And I need to hurry for this last one, so I'm running out of time for this video. But again, it's inverse tangent. Just type it in that way. Second tan of negative 0.892. But again, we're going to get a wrong answer. And the reason why that answer is wrong is because we're going clockwise. Again, it's poorly drawn here. 0.733. So how can we get a correct answer? Now, one answer is just adding 360 to it. But before I do that, let's think about another time when tangent is negative, and that is in the second quadrant, exactly 180 degrees later. So what I usually do is just add 180 to that to get one answer, and then add 180 again, because that adding 180 twice is like adding 360 once. So there and then there. And you get both answers. So add 180. So 138.267. And add 180 one more time. 318.267. And I think I want to share the answer key. So you might want to hit pause if you want to copy this down. This guy has another way of thinking of it. You don't have to do the problem my way, but my way does work. Doesn't always work for everybody. So I'll see you in the next video.